since then, like, she started saying that she was gonna work.
Oh yeah, we were doing exercises.
It worked.
Second period. That's why.
Why they always fall asleep?
That's why we had music.
But it's not. Wait, what's your big speech?
Well, math. Math. What it is, what it isn't.
How it relates to everything.
How it relates to everything.
And recording.
Where's my limits?
I'll tell you. Right
here, right?
No.
No.
Right there.
It's just like, don't go past there.
A little bit more? You can go a little bit more on that.
I have no idea what I'm even gonna write. Just got all this random crap here. It's gonna go on here.
The phone is ringing. Honestly, I wouldn't shut up. Was I talking to you? Oh, heck yeah. You have another one? Are you trying to make this? Am I there? Yeah. So this could be fresh. It's just a
Oh man, you hit the cold one.
Oh, there's a symbol.
I should have done it with bigger markers.
Okay. The reason I wanted to talk to you is because we're about to start graphing a lot of things.
Oh, you go shake that.
Oh. No, I was watching one of the videos of myself, and it was like the iPad was doing weird stuff like zoom in. It was all like psychedelic, and I hadn't even done any drugs or anything. It was like, I was like, what is going on? So maybe that's what it's doing. I don't know why it's doing it. So if it looks weird, don't adjust your TV sets at home. It's just the.
You look creepy.
Look creepy? Thanks.
Just talking to you.
Okay, graphing. Who likes to graph things?
No.
Show of hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15. It's like 27 of you.
Nobody writes. And you're not even in the shot.
Yeah, that's okay. Just talking.
Are you doing that speech today?
That's
What he's doing right now.
I'm starting. I don't know where I'm going to start. I have like all this stuff, but I don't know where to start.
Just start from
Start
The beginning of time.
Can I hold it?
whatever
Start
your
from the
heart tells
beginning.
you.
There was a guy named Adam. And he had
Not that far back.
Not that far back? That's where it all starts. Because don't follow me with it. Sometimes I want to be out of the screen. Then you mix it up what? Yeah. Where it all starts. Why is math? What is it? Because see, you guys think graphs are like these really hard things to do. It's so freaking easy.
For you.
You guys should just start right there. Start with graphs and what they are. But to start with graphs, you can't start with graphs. I gotta start back.
2 plus 2.
2 plus 2. The original math. That's like when people like didn't know anything, they could still go like, I have 2 goats, and then my goat just had 2 more kids, so now I have 4 goats. Right?
Sure.
That was like the first math problem.
I guess.
Yeah, goats usually have twins. Did you know that?
No.
Every time. I didn't know that either. So my neighbor, he got goats, and they started having babies.
Wait, you live like out of town?
Anyway.
I thought you lived in home.
My friend has chickens and goats in our neighborhood.
So anyway, adding. I'm going to call these operations. What math operations do you know? We'll just put this right in the middle.
Oh my god.
Math operations. These are important. These are like the basis for everything else.
Addition, subtraction, multiplication, and division.
Addition, subtraction, multiplication, and division.
You go, Ellie. You should get closer to the game.
Can you give me, there's some others. They're all based in those. What?
Square rooting.
Square rooting. someone's gonna watch this and be like, that's not an operation, technically it's blah, blah,
To the
blah, blah.
power
Exponents?
Exponents.
That's like an exponent, but we can go like,
Yeah,
I have to
X,
write it.
X second.
Like,
X to the Y.
3 squared.
Okay.
Exponents, but exponents are just what?
Repeated multiplication.
Repeated multiplication. And multiplication is really just
Repeated addition.
repeated addition. So it kind of all goes back to that. It's just faster ways of adding and faster ways of subtracting. Faster way to add a whole bunch of times is to multiply, and a faster way to multiply a whole bunch of times would be to do an exponent. So that's all that is. Math, you know any others? Absolute value.
I was about to say that.
I hate those. I don't know how to do it.
Don't know how to do absolute value?
It's just the distance away from zero.
Make the number positive. The end.
Hey,
Just taught you in 1 second.
awesome.
That's it. Alright, so those are operations. What are operations used for? Why? What do you think? Who do you think came up with these?
They did it so it's easier for math, right?
It was the Egyptians.
The,
Right?
no, those
That was
ones,
wrong.
like SpongeBob, those ones.
Some really old people, right?
Greeks.
Way before that. What? Oh. Let's see. So those are operations. We use operations to add, subtract, multiply numbers. See, so I was going through your standards of what you're supposed to know in high school.
What did you find out?
And what did I find out?
Half of them don't matter? Yeah.
Oh no, they matter. See, there's these things called number systems. What do you know about number systems? What's a number system? What? Oh, okay, I wasn't even going to go here, but our number system that we use. What do you know about it? What do you know about numbers?
They go
Infinite?
They go from 0 to
There's
100.
a pattern.
0 to...
Infinite.
How many...
0 to...
So we have real numbers,
Oh, that's imaginary.
and we have complex or imaginary numbers. And within real numbers, there were integers and whole numbers and natural numbers and
Rational number.
that quiz you all failed because you didn't take me seriously and didn't think it was going to be on the quiz. And okay, now I'm just talking. It was like first semester. And, no.
It was like
Oh, I got those right.
So with these numbers, we can do any of these things, right? We can add to them, we can subtract them, we can multiply them, we can divide them, we can do square roots of them, and we did it both with real and complex. Before this year, you had never seen anything with complex, you had just seen real numbers. Wasn't going to go here, but this is interesting. This will blow your minds. How many symbols do you know to represent numbers?
How many symbols?
Yeah.
Like
Isn't
negative?
it?
Like we're talking about
Infinite?
It's like
there's letters like X
Oh,
and
you mean
Y.
like-
No,
there's
symbols, though.
symbols.
that
Okay.
one.
Oh,
Let's stay away from
The
letters.
circle
Like
with the line
exclamation
through it.
points and pies? and
No, no, no. Oh, it's
Exclamation points, yeah.
What's the
And
circle with
the
circle
I.
Wait,
Oh,
hold
what
on.
about I? That's a letter. That's a letter.
okay.
I'm-
We're going the wrong direction. I just want to know. Okay, here.
Beta.
What about sine, cosine, and tangent?
Okay. I said the wrong word. This is not what I wanted. I'll just say this. How many numbers do you know?
You already asked that.
It
And we
goes
said
up
Honestly, I think I
Infinity?
only know like a
Yeah.
trillion.
How many numbers do you know? Not.
What if I told you there's only 10?
That's a lie.
Because 1, 2, 3, 0, 1, 2, 3, 4, 5, 6,
There's-
7, 8, 9.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that,
They repeat.
they repeat. And we have place value, right?
Yeah.
So like you have put 2 digits, and this one is the 10s, and this one is the 1s. So if you have like $23, that means you have 2 10s and 3 1s, right?
Yes.
Have you ever learned math in a different base? This is our number system on planet Earth that everybody uses for 99% of things. It's base 10. There are 10 symbols that represent numbers. That means 9 things. Oh, good, I got a magnet. I wasn't even going to talk like this. This is just completely made up. So 9, that's for this symbol represents this many things, right? What if we didn't have this many symbols?
Then it would be a small. No, it wouldn't matter.
What if we had like?
It would still be infinite.
What if we didn't know that symbol? We didn't know that symbol, and that's all we had.
Then you can never have like 6.
Then what? You can never have what?
You can never have like 68 of something.
Oh yes, you can.
79 or whatever.
Like, how would you know? Like, if I had
You
this,
just have to-
1, 2, 3, 4, 5, 6, 7, 8, 9. We
You
still
just
have the
to say,
word
like,
9.
3 plus.
How would I represent that many things?
That'd be a lot. I don't know.
You're close.
Somewhere.
This is called base 8. We use base 10. You can make this anything. Base 8 just means we only have 8 symbols that we know to represent numbers. And we could go like, this is the ones place. And now though, because we only go up to 7, when you get to 8, this is the 8's place. So this many things would be represented by 1, 8, and 1, 1.
See, I was right.
That's
11.
9. You ever heard of binary for computers?
I'm
They only
guessing
use
it'd be
zeros and
something-
ones.
Oh, yeah.
So all there is that. So if you have